Hey y'all, happy Sunday and welcome to this week's live Q&A session. This is the portion of the show where we allow YouTube to send out notifications that we're going live. If you're watching this live Q&A on replay, please scrub ahead until this graphic disappears and the actual show begins. If you're watching live and you have any comments or questions, please go ahead and put them in the live chat. But for now, grab a beverage, sit back, and relax while the countdown timer does its thing. Then we'll get started. Hey y'all, happy Sunday. Hope everybody's doing well. Hope you and yours are doing fine. Let's see. It's that time of year again wherein our cold, wet, foggy, rainy, drizzly, one of our cold, wet, foggy, nasty periods. But, hey, this too shall pass. We're also getting into that time of year where everybody's getting ready for, well, we are officially in the holiday season, I guess. So there's a lot of stuff going on. And it's about this time of year the emails increase of folks having problems. And a couple of the emails I have received, folks have either asked directly about it or their problem can be fixed with leads. So I'm going to talk a little bit about leads and incorporating them into the project today. It's fairly simple, but there are a few things that you'll need to remember. But before we get into that, I want to do a little bit of housekeeping by first of all talking about my friend Steve over at Harneal Media. Eh, I know I keep preaching about him, but I mean every word that I say. Now, I consider Steve to be a friend, but even if he wasn't a friend of mine, uh, you can't go wrong. I mean, if you are getting into a CNC business, if you are wanting to sell your products online, there is no better way than with a website with a dedicated web store. You can put your items up on that web store and not pay out commissions for all these other services that will remain nameless. uh, Steve can help you set up that web store. It's a fairly simple process. He can walk you through it or he can do it for you. It's that simple. He's very competitively priced. He can even help you with hooking you up with a print on demand company if you want to make merch, t-shirts, baseball caps, hoodies, things of that nature. He can help you set that up and you won't have to worry about inventory or anything like that. They print the orders on demand and they ship from worldwide. I use that service through Steve and I just can't sing his praises enough. He's very competitively priced and it's 100% personalized service. When you're dealing with Harneal Media, you're dealing with Steve 100% of the time, not somebody in the call center that you'll never ever meet. So you'll find a link to Harneal Media in every video on my channel, and I'm proud to keep it that way. On the subject for the day, I had a uh, channel member reach out to me and ask me specifically about incorporating leads into his project. And he has the perfect situation for using a lead. Now, for those who don't know what a lead is, let me switch over here to Aspire and we'll get into it. If you're in a situation like this where you have just a rectangle and he wants to pocket out this rectangle a specific depth, and then what he's doing is he's creating drawer pulls. And Oz, you are the man. Thank you very much for that $20 super chat, Oz. I truly appreciate it. Said it before and I'll say it again. I have the absolute best viewers on YouTube, and you guys prove it all the time. Thank you. It means more than you'll ever know. I appreciate it. This channel member, and again, I'm just going to address this kind of in a basic method. I do a members only live stream every Monday, 5:30 Pacific, 8:30 Eastern. I'm going to get into his specific case with him tomorrow evening on that live stream. But just it's something that bears talking about today simply because I've had 3 or 4 other emails from other people, and these problems can be fixed by using a lead. And what a lead is instead of your bit plunging down to start pocketing this material right straight on the inside of this vector, you can actually start that plunge somewhere out here in the middle where the bit is allowed to get up to the proper cutting depth out here, and you don't have that plunge mark here on the edge. This is especially important if you're using something like a compression bit. A compression bit, the bottom tip of the bit is an upcut spiral. Then you have a compression section. Then you have downcut up at the top. And that compression section is where the upcut meets the downcut. The reason for using that is so you get a nice clean cut surface on the top of the material and a nice clean surface at the bottom of the material. But in order for that to work, you have to plunge that compression bit down into the material past that upcut portion so that you're in the compression portion when your bit finally gets over here to the edge of that vector. So combining a lead with a ramp will let you plunge that bit out here in the waste that's going to be machined away so that by the time you get out here to this vector, it's cutting with the downcut portion of the bit. So using a lead will help you with that situation in conjunction with a ramp. Now, his situation, he wants to use a door lip finger grip bit. And if we look at the measurements on this bit, it creates an undercut. That right off the bat is going to give you some issues when it's time to program it into the tool database. You'll have to enter it as a end mill just to get it entered into the database. And if we look at the measurements of the cut, this is a side view of how that bit's going to cut. It's the total plunge needs to be 5/8 of an inch or around 16 millimeters. And the amount of space it's going to carve out with this tip of the bit right here is about 3/8 of an inch or roughly 10 millimeters. Well, you can't have that bit plunging down through the material like this to start cutting. So you'll need to start that cut somewhere out here. So let's look at how that would be taken care of within the Vectric software. So we have our vector here that we're going to machine to, and I haven't created any toolpaths for this yet, so we'll do it right now. Now, looking at the measurements of that bit, our depth needs to be 5/8 of an inch or roughly 16 millimeters. So that's how deep we're going to cut our pocket. So the first thing I'll do is I'll come up here and I'll do a pocket tool path. And I want that to be, since I use imperial, I'm going to enter this in inches, but just know that 5/8 of an inch is right around 16 millimeters. I believe that's what that said. Yeah, roughly 16 millimeters. So I don't write, see, 5/8 of an inch is 0.625, yes. And I'm not going to use a 1/4 inch end mill because this is such a big area. I'll go ahead and use my 1/2 inch end mill. And I'll go ahead and I'll do this in a raster, or excuse me, in an offset strategy, hollowing this out. And yeah, I'll go ahead and calculate it. Now I know the radius of my bit, I'm going to end up with rounded corners, and that's okay. I want those rounded corners. That's just fine. That's a stylistic thing. So we'll go ahead and we'll preview that toolpath. And now to incorporate a lead, what I want to do is I want to use a profile toolpath. So I'll come along here, close my preview, and I'll do a profile toolpath. Now, I don't have this bit entered into my tool database, so I'm going to kind of fake it here. I'll use my I'll go ahead and use my 1/2-inch end mill. I'm going to just imagine this is that bit. You know what? Actually, nah, I won't do that. So our cut depth is going to be the same, 0.625, and I want to cut on that vector. I want to cut to the inside of that vector because we're wanting to hollow out the inside and create that finger pull there. And I'm going to come down here. I don't want to do a separate last pass. I don't want to add any tabs, but I'm going to come over here to leads, and I'm going to add a lead. Now, because most of this is already going to be carved away, it doesn't really matter if I do a straight line lead or if I do a circular lead, because there's not going to be any material there. I'm going to go ahead and leave it a straight line lead with an angle of 90 degrees. And my lead length, because of the diameter of that bit, let's take a look at what the diameter of that bit is. The diameter, large D, let's, well, I'm going to have to look down. The diameter of that is 1 27/64. I'm going to go ahead and say 1.5 inches is how long I'm going to make my lead. So we'll go 1.5. I want the entire diameter of that bit to be out here, away from the edge. And I also want to do a lead out. And let's see here. I don't think I'll need to do an overcut. Yeah, I'll go ahead and I'll add an overcut of 0.5 inches. Now, what an overcut is when the lead starts, let's say it starts here, comes down to this. You know what I should have done? I can't do it now that I'm within the toolpath. I'll change it when we get finished here. Just basically the lead in is going to come into one area. It's going to cut, go all the way around, and it's going to overcut by 1/2 inch what it has already cut, just to make sure that there isn't a radius inside this area. So let's go ahead and calculate this toolpath. One or more leads. To avoid gouging, one or more leads had to be reduced in length or removed completely. Okay, let's go ahead and check it out and see what we get. All right, it took away that overcut, and this is what I thought. It's starting at the corner. So a mistake on my part. I'm going to go back into my 2D view. I'm going to uncheck this. I'm going to select the vector. I'm going to go into node editing, and right here in the middle, I'm going to insert a point. And I'm going to make that point my start point. So now this is where that vector is going to start cutting. So now I'll come out of node editing, go back into my toolpath. My lead is set up, everything's fine, and I'm going to come over here to start at. Start at, keep the current start point. So that's where this toolpath is going to start. So the bit's going to come in here and then start moving, cut around, and then go beyond a ½ inch, then lift up. Or then come back out here to the middle, then retract. So, and we're good there, we're good there, calculate. Uh-oh, maybe my overlap is too much. Yeah, it's too much. It's going to hit here. So let me reduce that. This is the problem with not having the that bit. All right, let's go ahead and jump over here to the 2D view, kind of zoom in on this, and I'm going to change my toolpath drawing style to solid instead of wireframe. And this is showing what this toolpath is going to cut. This is my lead in. It's going to come over here and then move over to the perimeter, then start cutting, go around, and then overcut by a ½ inch, then come back out into the middle and lift up. So a lead is used out here in the center of this that's already been carved away to drop that bit down to its cutting depth, then move over sideways, then start cutting the tool path. And because I used an overcut, it's going to go beyond that by a ½ inch, come back out into the middle, then retract out of that pocket. This type of a lead is very useful in a situation where you have, as I said, something that's going to create an undercut that needs to be moved into the edge, or like in the case of using a compression bit, where you want that tool path, you want that bit to plunge down to the cutting depth past that upcut portion of that bit so that it doesn't tear up the surface of the piece of material you're attempting to carve. So, I mean, I can go ahead and preview this, but you're not going to see much of anything because I used that ½ inch bit. So, there's no difference. It doesn't look any different. But that is basically a couple of situations on where you would use a lead. Now, let me go ahead and reset that preview, and we'll use another situation. We'll go ahead and we'll use this same vector. I'll do another profile toolpath. And let's say we're going to go ahead and cut all the way through with a compression bit. We'll do Z equals, and that's going to cut all the way through the material. I'm going to select my 1/4 inch end mill and select it. I want to cut to the outside on this vector. Let's see, Michael Hall says, would you have to start the second tool at 0.625 below the surface? That's an excellent question. Let me finish calculating this tool path, then I'll address this directly, because there's a couple of ways you can do it, and the choice is yours. So I've got my cut depth set. I've got the end mill selected. I'm going to cut to the outside. In this situation, because I'm cutting out this rectangle, I would do a separate last pass with a an allowance of 10 thousandths of an inch. I would probably add tabs. Edit our tabs. We'll go right there is good and right there is good. I'll put one here too. Close. And then I'll add a lead. And I can use a straight line lead. I don't have to do a lead length of that long. I'll just go 1 inch. I don't know that I need to go 1 inch, but that's a good starting point, and we'll start at our starting point. Okay. Something else I need to check on here, and I totally forgot to do it. We're going to get into our passes, and we're going to look edit passes, and I want to make sure that this first pass depth is at least the depth, a little bit beyond the depth of that upcut portion of the bit, because I want that first pass to be done at least in the compression section of that bit, not the upcut portion. Most bits have the upcut portion is anywhere from it's right 3/16 of an inch to 1/4 of an inch. And I know this doesn't mean much to metric folks. Let's say 0.25 inches is about 6.35 millimeters. So around 5 to 6 millimeters is the normal upcut portion of a compression bit. Some of them are a little bit less. Those made for home hobby CNC routers, for instance, the famous Jenny bit by Cadence Manufacturing and Design, his upcut portion is 1/8 of an inch, which is 3.175 millimeters. So it doesn't have to go as deep to get that upcut portion of that bit down in that material before it starts cutting on the vector. So we can go in here and we can make sure that our first pass is going to at least get that upcut portion down into the material. Now you can change these. It's showing us right here that for this bit, it's cutting 1/4 inch per pass. If I need to go a little bit more than that, let's say I have to go 0.27, I can change that here for my first pass. It says pass 1, the depth, I can change that to 0.27 and then click apply. Now my first pass is going to be 0.27 of an inch. I'm still going 3 passes, but the first pass is a little bit deeper than what it normally would be. Then I can come down here and click OK. And now I know that the first pass is going to be down, that upcut portion is going to be down in the material. So I can bring this down. And I've got a lead in and a lead out. I can calculate that. And now when we look at the toolpath here in the 3D view, we can see that my lead in, my bit's going to come over here, plunge down, and start cutting. Nope, that's the retract. I take that back. It's going to come straight down, plunge in here, and start cutting. Okay. Its first pass, it'll work its way around and come back down. If I switch over to my 2D view, I can see where that's going to happen. It's going to plunge down right here. Now I can do a straight plunge or I can ramp that in. And the way I would do that is back over here in that profile toolpath, I'll add ramps and I don't have to worry about anything else. I can just say ramp on lead in. So the bit, instead of plunging straight down to that 0.27, it's going to ramp in and be down at 0.27 when it gets here. And now let's calculate that. And now we can see the difference in the tool path. It's no longer going to plunge straight down to that cut depth and then move in. It's going to come down to the surface and then ramp its way down. So we should get a nice clean surface when this gets cut out. And we can look at the 2D view and see that that's indeed what's going to happen. These little half circles here indicate the tab. And if I switch over to solid instead of wireframe, we see where that bit's going to cut. So we can go ahead and go back to the 3D view. I'm going to slow it way down so we can see that ramp. And we'll get zoomed in here a little bit better. And I'll go ahead and draw the tool for this. We can see how that ramped right down to that depth. Then lifted up, it came over and ramped down to the next cutting depth. Lifted up, came over and ramped down to that next cutting depth. And when I back out of here, we can see that it ramps down to depth here, then starts cutting, then comes back out, retracts, come over, and ramp down to the next cutting depth. That keeps this edge as pristine as it can be. It just avoids all those witness marks running down the side or the edge of the project that you're just going to have to come along and sand away even further. So leads combined with ramps, it's a very good option. If you combine the ramps and leads, come on, get in there, with a separate last pass, that separate last pass is the final pass will be the first two passes in this case will be cut 10 thousandths of an inch away from that vector from final size. With that separate last pass, when it comes out here and retracts and then starts ramping in, it will go the full length, the full depth, that 10 thousandths of an inch, and cut that entire edge at full depth, giving you a nice pristine edge. You won't have those witness marks for every pass on the edge of your project. It'll be a nice smooth cut, and it'll really improve the cut quality. I'm here to tell you. So that'll help as far as that is concerned. I use a separate last pass whenever I can. Just about every profile cutout I do, unless there's something that would prevent me from doing it, I use a separate last pass with a machining allowance of 10 thousandths of an inch. And for you metric folks, 10 thousandths of an inch is 0.01. That's about a quarter of a millimeter. It's 0.254 millimeters. So that's going to give you your best edge. And it's also, again, when used in conjunction with something like a dovetail bit or a this drawer pull lip bit, that's going to give you a nice clean edge and allow that bit to get up into cutting position without damaging the edges out here. Now, Michael Hall said, would you have to start that second tool at 0.625 below the surface? Now, you have a couple of ways to go on this, and this is a valid point. It's a good question because you certainly could, but you don't have to. Let's go back into that tool path. I'm using a start depth of 0 out here. So from the material surface, and I want it to cut 0.625 deep. And I see one mistake I made on that. Edit passes. I only need one pass because everything has already been machined out. This is done after that pocket tool path. So what I can do is come down here and do one set passes. It's going to cut this full depth. And again, that's already been machined away. All we're doing is carving into the edge here. We're not cutting anything out of this pocket. So that was a mistake on my part. I should have set that to one pass. Click OK. Now here, that doesn't really, the cutting depth doesn't really matter. Well, the cutting depth does matter, but the start depth with a cut depth of 0.625, that is one way to do it. But you could just as easily have a start depth of 0.625 and a cut depth of 0. The important part is not so much where you start as it is how deep you're cutting into the material. And in this case, it's a case of 6 in one hand and half a dozen in the other. It all equals out to be the same. What's important is your overall cut depth. And remember, when you're dealing with start depths and cut depths, this plus this equals the total depth of your cut. So if we want the total depth of the cut to be 0.625, we can set our start depth, if it's already been hogged out here, we can set our start depth at 0.625 and a cut depth of 0. Or we can start at 0 and have a cut depth of 0.625. As long as these two add up to the total depth of our cut, we're fine. Okay, so Michael, yeah, either way is equal. They will both give you the same result. Personally, I don't think it matters. I really don't think it matters. I think it's all the same. The only thing is make sure that you're doing the correct number of passes. And again, that should be 1. Oops, it didn't take. I didn't set the number of passes. 1 set passes. Okay, now we'll calculate. Yeah, one or more leads were clipped. And now that's what we have. Preview selected tool path, and there we go. Still just one pass either way, correct? Yes. One pass. And the reason for that is when the edge of this bit comes along and starts cutting, you don't want this to start at the surface and then start cutting into your drawer pull area. You want this to start cutting down at the bottom of this pocket. You don't want it to get down there in 3 ways because it's just going to machine everything away on its way down. But since all of this should be already pocketed out because we would run our pocket first, but because there's nothing out here, we're not cutting anything out of this area. We're cutting it out of here. Okay. So let me go ahead and reset see that preview. Were there any questions on leads or combining ramps with leads or combining ramps, leads, and a separate last pass or anything of that nature? Now, I kind of convoluted that a little bit because I made a couple of mistakes in the middle there. I do have a video, and in fact, I have a couple of video um, where I used leads, then ramps and leads in one video, and then in the next video, I used ramps, leads, and a separate last pass. And I will find links to those videos and post them in the description as soon as we're finished here. So let me make a note to go ahead and post a link to that down in the description of this live stream as soon as we're finished. Now, Dwayne Ruthig says, I can see using this with a dovetail bit to chamfer the bottom side rather than flipping. Yeah, you certainly could. But you would need to make sure that, now let's see. You would need to make sure that the area underneath, let's go back over here and let's do this profile here. We'll preview that and I can speed that up because we've seen it cut. We would need to make sure that the area underneath the material will allow that. So if you have this in a fixture or something like that, it'll need to be fixtured up so that the bit doesn't cut into your fixture. But yeah, you certainly could use it in conjunction with a dovetail bit to chamfer the bottom. Yeah, you certainly could. So let's see here. John says, is there any way to have it move to the width of the cut when the bit hits the bottom of the pocket to take cutting pressure off the bit? Yeah, you could have the width of the cut when the width hits the bottom of the pocket to take cutting pressure off the bit. Move the width of the cut. You would basically, what you would do, if I'm reading you right, John, you're talking about have it cut in a certain distance and then work its way around, then move in a little bit more and work its way around, and then move in a little bit more and work its way around to your final width. You can do that. You would have to create, yeah, say take 2 or 3 cuts to get the total width. Yes, you can. There's a couple of ways to do it. One would be to offset this vector inwards a little bit. Let's say you want it to, let's say you offset it in 1/8 of an inch and just create a new vector. Let me close this. Do I have? Yes, I do have. Let me go back over here, reset the preview, close. You could either, one of two ways that I can think of right off the top of my head. You could go, let's go back into profile one, that is this one here. You could do an offset allowance, calculated toolpath, then create another profile toolpath with a different offset allowance. Let's say, okay, this is going to be our final pass. So let's change the name of this. We'll call it final profile and calculate it. Okay, that's fine. Now I want to create, or close this. Now I want to create another profile toolpath. And this time I'm going to use an allowance offset. Let me see if I've got this right. I want to go further to the inside. So I think that would be a positive number. Let's go 125. And everything else the same. Everything else the same. And we'll call it second pass. Calculate. Let's make sure that I've got this correct. See if it needs to be a negative number or a positive number. Let's take that out. Yes, this is the right one. Okay, so this would come down. All right. Then we'll close that, uncheck this, and now I'll do another profile toolpath, and I'll do an allowance offset of 0.25, and everything else the same. Add leads, everything else the same, and we'll call this first pass profile. Calculate. Yeah, I know the lead's been clipped. And now I'll bring that up. Okay. Here's what we're talking about, y'all. What we're talking about doing is, and let me uncheck that. Well, no, I'll leave that checked. On this toolpath, the bit's going to come down and it's going to come in until it's 1/4 of an inch away from this final profile. And that is so this edge of the bit is not trying to carve this full depth all at once. Okay, we're talking about a depth here, small d. That depth is 5/8 of an inch. Again, about 16 millimeters. So the first pass would come in at still really not enough, but just using John's example, instead of this bit going sideways and trying to cut this full depth here, it's moving in incrementally, making one pass, cutting a certain distance, one pass cutting here, then the next pass cutting here, then the third pass cutting all the way out to the vector. Okay, so you're making 3 separate tool paths, but because those tool paths use the same bit, we could conceivably either group those tool paths or just save the G code in this order, making sure we have them in this order. And then save the toolpath, save our G code, and go on with it. But basically what you're doing is you're bringing that bit down out here where it's already been hogged out, and then you're coming in just slightly. In this case, you're coming in about 1/8 of an inch and carving away that material. Then on the next pass, you're moving it in. Wouldn't a pocketing toolpath do this? In Fusion, you can just select the number of passes. Yes, the number of passes in depth, but not the number of passes in X or Y, the number of passes in Z. Now, this is, again, for a drawer pull bit that's going to it's going to carve that type of profile. So you're just moving that cutting edge in 3/8 of an inch, it says. Okay. So you're okay. In Fusion, you can do both. In the Vectric software, let's see. You can do this as a pocket, but a pocket is just going to, you're using a pocket to carve all this out. Yes, it's an undercut. This is for a drawer pull. It's an undercut. So that's why you're using the profile toolpath to ease the cutting edge into this undercut. And that's why we're plunging to full cutting depth out here and easing in using a lead. See? And Vectric software won't allow you to, I don't think it'll allow you to step in like that. So, okay, the fact that it's an undercut is what I was missing. Yes, yes. So, yes. Let's see. And they also have this type of bit here that leaves that type of radius because it does create an undercut. You would do the same thing. Now that's only 3/32 of an inch, about 2.3 millimeters. So it's not all that much. You could do that in one pass. But with this undercut being 3/8 of an inch, you'd want to do it in 1/8 increments. So, yeah, excellent point, John. I was kind of looking at that and wondering, I don't know, but what the heck? Dwayne says Michael has a good idea above. Yes, an alternative duplicate tool path and change the offset. Yes. Yeah, that's what I just showed, was changing the offset. An alternative to that would be to create separate vectors. So you could offset this vector in 1/8 of an inch and then offset that vector in 1/8 of an inch and cut each one of your profiles to the different vectors. But you end up with a whole bunch of vectors here to keep track of, which may or may not be a bad thing. I mean, it's only 3. But using a profile with an allowance offset, in this case, a positive offset, to space that tool out away from the vector, it accomplishes the same thing and you're using the same vector. So again, there are many ways of skinning that proverbial cat, and it's 100% up to you on how you do that. But excellent point, John. Excellent point. Now, I'm saying this, John, and it's taking away my idea for tomorrow, but we'll get into it because the member who wanted to know about this is not here. But I thought this was a worthwhile thing to talk about. So that is leads. Bob Helped Bridle says it works like your keyhole bit. Yeah, pretty much. And if we go back and take a look at this bit, that's basically what this is. This is a ginormous keyhole bit that instead of that has a cutting edge along the top that's angled instead of straight. So, you know, um, I said that there were a couple of things to remember, and one of them being this, and there's no way I can blow up this picture. If we look at this bit, the cutting edge does not go all the way across the bottom. The cutting edge stops just shy of the center of the bit. So if you don't hog this out with a pocket tool path first, you potentially could crash this. You could very easily crash it, as a matter of fact, because there's nothing here to clear away the material under the very center of that bit. Now, you could do it, and as long as you ramp it in. But personally, I think just hogging that out with, in my case, my 1/2 inch bit is the better way to go. So uh, and that is a rule for more than just this bit. If you're using a surfacing bit or something of that nature, like my surfacing bit is 3 wings and has 3 carbide cutters, replaceable carbide inserts along the outside edge, but no cutting edge across the bottom at all. If I try to plunge that straight down and just start cutting, this area here where there is no cutting edge is going to bottom out on the surface of the material, and you're asking for trouble. So all of my plunges have to be ramped in. And that's something to remember no matter what kind of bit you're using. So, are there any questions about leads and when you would use it and when you wouldn't use it, and anything else? The lead direction, whether it be on the inside or outside of the vector, that is determined by whether you are cutting inside the vector or outside the vector. And what I mean by that is over here on, let's look at final profile. That's easy. Because I'm cutting to the inside of the vector, that's going to put my leads right here. Come on, my mouse is slow. Was it this one? Yes, on this one, I'm cutting the outside of the vector, so my leads are going to be on the outside. So you just have to make sure to remember that. Keep that in your mind. If you want the lead in here, cut to the inside of the vector. If you want the leads out here, outside of the vector. So close that up, come back over here. So are there any questions at all about leads, ramps and leads? Yeah, I agree. And every time I say it, I hesitate to say it, but it's something most folks understand. It's one of those hackneyed old cliches that we don't know why we say it. We just do. But that leads something interesting. If Do you have a phrase that you like to use that means there are many ways to do the same thing? I mean, I guess I could just say there are many ways to do the same thing, but what fun would that be? So, um, wow, we spent an hour on that. Wow, I'm surprised. Okay. Um, so if there are no questions out there, really, I'm that good? You guys are just brilliant. I mean, perfect. Um, if that's the case, if there are no questions, no comments, no concerns, none of that, let me just reiterate that it's that time of year, it's that time of season, and we tend to put a lot of pressure on ourselves to make sure we get everything done. I know it, I understand it, and just remember that the number one cause of pressure is ourselves. It's okay to stop, sit down, and think. It's okay to stop and breathe. The number one cause of pressure, again, is ourselves. Um, just take it easy. Don't let the pressure of the season make you forget what's really the important part of the season. Okay. Um, yeah, exactly, Michael. Breathe in, breathe out, move on. It's okay to take a break. It's okay to take a rest. It's okay to go grab your significant other and go out to dinner and just spend time with one another and let everything go just for a little bit. I find that I make most of my mistakes when I put that pressure on myself. I got to get it done, got to get it done, got to get it done. I used to say in the Army, we never have time to do it right, but we always seem to find the time to do it over. So pace yourself. It's okay. You're going to make it through another one. Um, hug those around you and don't take anything for granted because you never know. Rob, I'm not ignoring you. Um, I'd like to find out how all that went. I saw up above you guys had a good turnout, and I'm really glad to hear that. Um, let's see, and what am I talking about? Saturday, yesterday, our buddy Rob Schuster and Cody Elkins over at Cadence Manufacturing Design, maker of the famous Ginny Bit, amongst others. They had a Arizona CNC meetup yesterday. He says at least one person, I think more, came because you mentioned the event. Thanks so much. Hey, Rob, glad to help in any way I possibly can. Um, I hope everybody had a good time, and I hope you'll make it an annual thing. Um, uh, I love stuff like that. I just wish there was something like that around me, but no such luck. Yes, John. I also would like to say thank you to any and all veterans out there. Oh, Sargon, man, you go way above and beyond. You go way above and beyond, man. Thank you sincerely, more than you'll ever know. I truly appreciate it. Um, I truly appreciate it. If you're down in Orange County, California, you're looking for some laser work, there's your man. There's your man. Sargon. There's your man. Thank you, sir. Greg, we'll get to you real fast, and then I got to jump. Um, any suggestions or info on a good dust chute for a spindle? I am very partial. I am very biased to, you can't see it, Keith Moreland over at One Guy in a Shop on Etsy. One Guy in a Shop. That is an absolutely awesome dust boot on my spindle. And Keith is a stand-up guy. If he makes dust shoes for, I mean, all kinds of different CNCs. And if he doesn't have one to fit yours, he'll work with you to make sure you do. He'll work with you to make it. And he's worked with a couple of people on, like, for instance, the 8 horsepower Avid dust spindle. We're talking, he sent one, it had a couple problems, they needed to refine it, send it back, he printed another one, sent it back. The guy is awesome, and this thing just does not let dust out. That's it. It's unbelievable to me how well it works. And so One Guy in a Shop on Etsy, man, he's good. Keith Moreland is his name, and I endorse him 100%. Okay, let's go ahead and wrap this up. I am in the Ray Russell says his is coming tomorrow. You're gonna love it. Um, uh, I am in that time of year where I have Steve, the man, the myth, the legend. This is what I'm talking about with Steve. I mean, the dude's on it. Um, this is traditionally the time of year where I put my channel on hiatus because I've got to focus on Christmas. I haven't put out a whole heck of a lot of videos this year. So you're not going to notice any difference. But what I'm going to attempt to do is much like today. I'm going to try to have a topic to discuss um, for each one of these live streams. Hopefully, something that'll help you with you making your Christmas projects. So leave me a comment. Let me know, what is it that you want to see. Do you want to see me do a little bit deeper dive onto one certain process, a certain tool, a certain tool path, a certain design element? What do you need to see? I can't work on individual files, but I can try to help you wrap your head around something that is still a little bit mysterious to you. But I need to know what that is. So at least until the new year, every Sunday, we'll have a topic to discuss, as well as your questions, your comments, concerns, demands for payment, demands to turn that music down and stop it. It's all about you guys. So let me know what you want to see. Leave me a comment. Channel members, tomorrow we're going to do a little bit more talking about leads, ramps, separate last pass, as well as 2 other topics that were sent to me over the course of the week. Hopefully I can get them all in. If not, then that gives me something to talk about next week. If you don't know what I'm talking about, or if you'd like information on how to become a channel member, just click that join button next to the subscribe button. A panel will pop up and a video will play. That video will tell you all about channel membership. We have a great community of people over there um, on the channel member side. We have a lot of fun. Unlike this live stream, it's not time limited. I'll go until y'all get tired of me. Uh, Thank you to all my channel members for becoming channel members. Thank you to Sargon and to Oz for the super chat and super stickers. Thank you, everybody, for watching my videos, sharing my videos, commenting on my videos, giving me those thumbs up. All of it mean the world to me. And until next week, Breathe in, breathe out, move on. Y'all take care. Thank you very much for everything.